Well, I can just say how happy I am here to talk to so many people at Validas. That's really great, and I think that's one thing that we have been growing quite fast in the last year. So we are now 50 people, and the contract was sent to the 51st today, I think. And also we have more guests from external. Last year we had the first event of this let's say Christmas talk. Is your recording?
Yeah.
Okay, we had the first event of the Christmas talk, and we were presenting PMT. PMT is our process modeling tool, was a research result, and what was so interesting, we invited also many people, but I think except from Validas 3 or 5 people came, and were not so interesting. And today, from our standpoint of view, we just have an application of the PMT tool to create a safety plan for software and to have an example for Linux. So this is more attractive, but for us it's just the next step which we continued here, and we are happy to see this broad interest here. Well, but before starting with the talk, I'd like to thank the team that helped me in developing the work and also the slides, especially Felix, Reinhard, and Benjamin, who improved the slides, so we will have hopefully nice slides, and well, if not, you can blame me, I'm always responsible. Okay, well, then let's start today. We present software validation kits for ISO 262 compliance and other things. And these are safety standards, and we have developed a method to create those safety plans, and we can apply them to arbitrary software, and we can also apply them to Linux as we have showed them, even if we're currently considering only small parts of it. We have rolled out the process here, so afterwards you can have a look to this process where it's presented here, so you can see those images that have been generated from the PMT tool, but you will also see them in the slides. Well, let's step into. First thing I want to say some words about Validas, and then I come to some safety requirements for software, and go to the development and validation process. And then we look to the Linux example with the live kernel patch feature, which is a cool feature, and we discussed whether we can qualify it or make it safe, or let's say complete the safety development. And we will discuss also a bit of the terminology. What is qualification, what is validation, what is prototyping. Today I heard from someone who says, well, I'm very concerned about prototyping and making prototypes safe. That's not developing software. We should discuss these concerns, of course, as well. Yes, who are we at Validas? So you see a part of the team here in Validas, and you see here also an old photo of Validas, and it's mainly it's driven or guided from me and Peter, but our mission is to guide the world, to make the world a safer place. So we will work with our customers to guide, build safe systems worldwide. So next week I'll go to Boston, and we have cooperation with China and all over the world. And our contribution is to make safe tools, safe methods, and safe libraries. So we are specialized, and this is the only company which is specialized on tool and library qualification. And nobody would have thought that we are such a big company just with this very small topic. But being specialists and having a growing topic somehow pays off. We also run the Tool and Library Qualification podcast, the only one which is in the safety field, as far as I know. And so you have some way to hear about the Tool and Library Qualification. Yes, history of topics. We started with model-based development and testing in 2001. I'll just make it a bit shorter. The first tool qualification we did, and I'm very happy that Martin is with us here, so he was a pioneer in doing tool qualification with target links. We started out and building some qualification suites in 2006. We did tool test in 2007, and we did build the Tool Chain Analyzer tool in 2010 when the ISO 262 appears, and this computes the tool confidence level automatically based on the model. And this was somehow also our starting point to do model-based safety analysis and processes. Yes, we started in 2012 to build tool and library qualification kits to support the qualification. This is for classification, This is for qualification of tools and libraries. And in 2020, we will deliver the first validation kit for software. And I'll explain these degrees in a later slide. Yes, that's our topics. We are centered around tool and library qualification. We do tool classification, tool chain analysis, tool testing, tool automatization, continuous testing, and we guide our users to use the tool safely. And of course, we also help them to manage the tool chain and to see which tool is critical and things like that. And basic technologies are neural networks and AutoSAR because there are so many tools involved that we think this is a core competence that we need to have in the modern world. Yes, that's the podcast. You can find it on Spotify or on iTunes or on the home page, something like that. And Ivana isn't here today, but she asked me all the questions that I love to answer about tool and library qualification. Yes, let's look a bit to the safety requirements. What is safety requirements in software? And of course, when you want to build a safe system, independent of what kind of system is, you have to have safe hardware, safe software, and safe tools. And the safety of tools is which we are worldwide focusing on it, and also these libraries that somehow come with a TÜV. With the tools. Sometimes they come with the TÜV, but they come with the tools, or they come independently. And of course, the application software is something then the most critical here to be considered. With safety, there is something. Safety is a bit. You can compare safety and safety integrity, which is a good term to understand. So safety means like being a safe driver. And while safety integrity means have a driver's license. And we might discuss whether those two topics are related. Can you be a safe driver without a license? What if police stops you? So how can you argue without having a driver's license to be safe? But the other way around, if you have a driver's license, you can drive like an idiot. So that's the two things that need to be considered. And I think we need both. And we are aiming at both. And of course, we want to make the world safer, but also we want to be compliant in case a police stops us, and we don't want to go to prison. And when you look to the recent case, which was in last year, where Uber car killed a person on the street, now they have analyzed the case, and the main point of accusation is not that they killed somebody, but that they didn't have a driver's license, meaning a safety plan. And this was the headline, I can provide it to you, is Uber did not have a safety plan. This was really what they missed. So, of course, it's very tragical that they killed a person, but they didn't have a driver's license, meaning a safety plan. So no documents in place. So they might have thought about it, but obviously not in the right format. And that's something that we, of course, try to avoid. And we want to make things safe, but also compliant. And the difference between safety and compliance is if you happen to have a big incident or whatever, really bad luck, well, that's tragical and you need to pay people and repair the damage and things like that. But if you don't have the driver's license, then you go to prison. And that's a big difference. And when you work with Validas, you hopefully improve the safety, but you don't go to prison in any case. And I have heard a talk where a person was asked, hey, if you work with us, you can make the safety plan and safety case and whatever. And then he was asked if he's responsible for it. And then a bit of thinking said, well, in case something happens, you will have a good friend, I'll go to prison with you. And that's not our aim. Our aim is to say, okay, we do everything that you are compliant and to increase the safety of the system. Well, that's just a general thought about safety. When you look to a safety standard, and here I just take the ISO 262 as an example, but other standards are in a similar form. So we have here the three domains: hardware, software, and tools, and libraries. And we have also three different criticalities. So we have the software part, which is here described, which is the red part, so which is the most requirements to satisfy part 6 in the ISO. For software libraries, and I come to this, there's a chapter, you can say it's not so rigorous, therefore it's just yellow. And for tools, it's even less rigorous. So the tools don't go into the product. They don't belong to the car, and therefore they are not so critical. And therefore we mark them here as green. And when you see the landscape, then you see, okay, there are software for 3 different systems here, different software, they are most critical. Then there are libraries that are used in all these 3 systems, and therefore people think that it's not so critical, which is usually the case because they are quite stable and also mostly smaller components, and they go into the cars together with the software by the tools. So that is somehow the landscape. And as we said, we are specialized on tools and libraries, but today's talk will also be applicable to software. And that's of course a big challenge, because let me say something about the requirements. Maybe for tools we have about 80 requirements in the ISO 262 to be compliant, which are even very flexible. You can always argue, well, this tool is uncritical and don't need to qualify it. With libraries you have less requirements, maybe 50, but a library has always to be qualified. So no library in the car without being qualified. And the third one is software. There's part 6, and there are some related parts which are required, and I think it's about 300 to 500 requirements. So it's much more to do and much more to be compliant with. And you can see our compliance report there. Mohammed, maybe you can lift it. That's the compliance report. You can have it around that we have been creating to document that we are compliant with this approach to ISO 262. And I'll show you how we did this in some of the next slides. But first, let me define some basic terms. So it will be around prototyping, which is something which is even recommended to verify things in the ISO 262. And we consider a software that is existing as a kind of prototype, meaning the software is already existing, but this is not the final software, this is just a prototype. And then we have the software, which is then developed according to ISO 262, starting from requirements, as you see, and then going to an architecture, which is, of course, the architecture of the prototype, if it's working well. But this will be documented in the sound form, in the compliant form, and that is somehow the prototyping and software differentiation. We will come to this in the implementation phase, where we'll see how, from the prototype, we make the step to the software. Then a library is a pre-existing and unchanged software. So in the moment where you start to change the software, the library, it isn't, you can introduce errors, and therefore you have to develop it as ordinary software if you change something, which is natural. But if you take it without changing it, then the software is to be considered as pre-existing. And we call those things libraries, because usually they are libraries, even if other things may also be technically deployed as a library, but in our terminology, a library qualification is a qualification of a pre-existing software. Well, tool is something, as I said, not part of the product, just to test or develop and compile and other things, manage requirements and architectures. And interesting is the term qualification. Well, qualification means, of course, making it fit, making it safe, but it's usually applied only to pre-existing software and tools. So when I come up with the idea to ELISA Foundation, hey, we can qualify software, I said, no, we don't want to qualify software, because we want to have a validation of the software to be it really ISO compliant. And qualification, the word is somehow only used here for tools and libraries. And if you have new software, you don't want to qualify it. You want to develop it according to software, and this needs to be validated and verified. And then we are on those two terms. Of course, verification is always saying that I did the thing correctly, where validation means that I did the correct thing. But you can see this also more formally saying, okay, verification is something like a test, a review, or prototyping, where you really can verify that your requirements are satisfied or that your criteria are satisfied. And here for us, the validation is somehow the modeling and the review things, or the bit more softy things. And we built a validation kit. A validation kit is somehow a model-based, you can say qualification kit, but you shouldn't. It's somehow, in our technology terms, it will be the same thing, running some test cases on the system and verifying that it is correct. And this validation kit could be called a verification kit because it's running test cases and doing coverage measurement and those things. But we call it validation kit because building it is the main part of the validation. You need to think on the software, define the specification, is it correct, what about the architecture, is it safe, and so on. So therefore, we have some validation kits also because Validas and validation is something that is in our history since 20 years. So when we founded Validas AG, we called it Validas Model Validation AG because we are very close to the idea forever to validate things to make it better. Okay, that's something about the terminology and things, and these are the 3 levels of Q-kits or kits that we are supporting. So we have as basis since 2012 these tool qualification kits. We have since 2015 the library qualification kits, and since 2020 we will have the software validation kits. And of course there are different contents here, but main things is a test automation unit that is here in all of these qualification kits that runs the test on the target. There are specifications and there are test cases in it, and of course the more upper you go, the more things you have to do and the more documents you have to generate and so on. Yes, and we have these 3 qualification kits which are for us quite similar. So you will get a kit with an executable in it and a tau in it and test cases, so they look very similar, but there's a big difference. And the biggest difference is the compliance argumentation. Qualification kits for tools need to be compliant in ISO 262 with chapter 8.11, confidence in the use of software tools. For the library qualification, the ISO has a different chapter with a complete different argumentation. So we cannot reuse anything when going from here to here. We have to start from scratch, except maybe the general function, safety management, and our processes and those stuff. But for the argumentation, it's a completely new one. And then we can throw away almost everything and start with a safety element out of context, which of course also relates to tool qualification and to library qualification things. They include it somehow, but this argumentation is completely different. Yes, and how do we do these argumentations? We have a process modeling tool that I initially told you from last year that we can model the processes, and we model the requirements. So we formalize the way how to build those kits, and we formalize the ISO 262 requirements and IEC requirements and other requirements there. And then we link the requirements to the process. And that's somehow our compliance argumentation. We say this requirement 8.11.4.3 is satisfied because we do this and this, and we verify it. We link every requirement twice, and that's of course a bit of extra work, but it pays off because once we link it to a process, how we do it, and the other thing we link it to a verification criterion, like a question, how we verify it. And this is some very cool thing. We can just tailor it a bit because we have a single source model, and then we generate a process description of how we do things, and also how we verify things, and a compliance report with all the requirements and all the arguments that we are compliant. And those 2 things we give to TÜV, and we have got a certificate for this, that we are compliant with the requirements that we have formalized here. Currently we have the certificate only for 8.11, but hopefully we'll get it for more soon, because customer requesting it to have a good process for those things. So this is somehow our safety plan. And the safety plan is the thing that we want to have to build a safe product. And interesting is this verification validation scheme or plan, as we call this, because these are all the questions that need to be answered for every product. When we build a qualification of a small software, we may have 3 or 5 functions, and we build a software for a big software, we might have 100 functions. But always the question, is the function specified correctly, is it tested correctly, is the code coverage okay, and so on. And there are some questions we need to answer per function. Of course, there are also some general questions like, what about your programming guidelines? Do they this and this and this? There are also questions which are general. So there are different kind of questions that need to be answered depending on the qualification kit we build. So, and this is project-specific verification and validation we do for every project. And because only if we have done this successfully, we know that the product will be compliant to the standard. This is our safety plan, but for the safety case, we need to do a bit more. And as you might know, we are using the Tool Chain Analyzer tool to build our kits. And this Tool Chain Analyzer tool can export, let's say, the number of functions that we have qualified, or the number of features of the tool, the number of tools, the number of use cases. All those data can be exported into our verification validation tool, and this then does the multiplication. It reads in the schema here with the different questions, and it reads in the parameter with the different instances, creates a big matrix, and asks people to verify it. And once then it collects the results and does a verification report, and that's our safety case. And this is applicable to all the products that we are building. And currently I'll show it how it can be applied to part 6. Okay, and the newest feature of our PMT tool is also to generate a development interface agreement. So this is a very specific document required from the safety standards if one provider of a safety element needs help. So then he just sources it out, and the question is, will the other company be safe? Will they deliver right things? And then they have this development interface agreement saying, okay, we need to have a software verification plan, a software verification report. Will you deliver this? And this is somehow the development interface agreement. And if people say, yes, please Validas do both, then we will offer both. And if they say, well, we will do the planning and you do the verification, then we just offer this. So we agree on who is doing what. And of course, we can feed this into our offer generator and generate an offer. So everything comes from this process model, which is then very nice. We can describe here which process steps we have in the offer and which deliverables we have, because all is in the process. So this is really cool and quite a new feature we added to the PMT tool, offer generation. Okay, well, let's come to the process that we have. This was a bit the infrastructure that I described you, but now let's come to the process, why you are here to see how we can develop safe software based on prototyping. So there is a prototype from the system and maybe from the software as well. Let's call it Linux or any other library. And we, from the prototyping, we learn something. We learn how many tasks we need to schedule, what are the critical functions, what is a good architecture. And that's something that we can specify here in our validation model. And of course, we need to start here with the requirements, and then the architecture, and then the units. Everything needs to be specified in this model. And of course also the test cases for it. So this will not be an executable model like MATLAB Simulink or other really complete modeling languages. This is an abstract model, I would say, on the architecture level. So we model the finest granularity we have is a feature or a function of the software. And we don't go there into more details, we just have the specification there. So it's somehow complementing the implementation and the test cases by documentation. We might call this also a documentation model. Well, and now let's have a look to the clauses of the ISO 262. So the main clause starts with clause 5, general processes. And there are two objectives to set up the process, which should look like this here. Specification requirements, architecture and design, and of course we have to have some guidelines and some rules how to model it, modeling guidelines, coding guidelines, things like that. And maybe impressive, okay, we have a way to model architecture in our TCA tool to express the features and the types and the relationships with input-output parameters, global variables. So we have modeling guidelines how to model software within the TCA. There will be small changes in the TCA only necessary to model software, but this will be then the variant TCA for software, which we will issue in the next 1 or 2 months. Okay, well, and then of course we have we will model the requirements as use cases. We model the architecture as feature trees. We model the implementation as the leaves in the thing, and we model the test cases as in the test suite model. So this is covering all the things we need to have. An interesting question, and feel free to ask questions if you have. What about the coding guidelines? ISO 262 requires to have coding guidelines. Do you know which coding guidelines has Linux? Nobody knows. There are no. Maybe there are some things, but they didn't agree on something like the Misra lines or the other things. But we will have a look to the Linux implementation code, some parts, and what can we do as a coding guideline without changing all the implementation of Linux? Any ideas? Well, and the ISO 262 does not describe you should use Misra. So just you should use something as a guideline, for example Misra, but you should not have 2 entry points in the same function. You should not have unconditional jumps. You should not have, there are some really hard requirements, and there are some coding guidelines that you should have to satisfy this. And our coding guideline is to have a readable and understandable code. That is our coding guideline. So we will look to the code, and we'll do this within the Linux system, and we want to understand it. Why do we want to understand it? 2 reasons. One is to make it safe. In order to understand and say, okay, I've understood the way how they do lists in Linux, which is a cool way how to hack or implement lists generically with different types. This is really a cool implementation. We can understand it. And that's the first thing. And the second thing is we need to model it. And if we don't specify it, if we cannot say, I don't know what this function is doing, no idea, then this is bad. So it falls through our guidelines. And of course, this also applies to the tools we are using. For example, we are using static analysis tools to compute some architecture. So the call tree and the value ranges and those things we'll do using static analysis. But if you know the Linux kernel implementation, instead of having a subset, they have GCC extensions. So they have a larger set than C, which is very hard to analyze. And if we cannot analyze the system using some tools, then we say no. And currently we're making an experiment with the Astray tool and trying to parse the Linux thing. And if it fails there, we will say no way. But if they succeed in creating a call tree that we need to understand the system, then we can say, yes, this is interesting. We have understood it, and it looks safe. And then we can do the architecture analysis, and things become later. So this is the reason what we consider to be a safe coding guideline. And safety always comes from redundancy and somebody else checking something. So we think this is a perfect coding guideline to have something understandable, if it's even compliant. Some checks are there, but that's the main idea of having this general clause. Yes, I talked about this modeling coding guidelines already. And this is a way how we can model this within the TCA, saying, okay, we have here a feature, and then this is maybe a module in Linux kernel. We have external modules and internal modules, and we have some directories where they are structured, and then there are some files where the implementations are in, and then we have the single function level, say, okay, here's a feature KLP patch function, which is kernel Linux patch, and then some functions there, and we can specify here that this function depends on other functions, and describe the architecture and things like that within the model. Well, how does the process look like? And this is from the PMT model. I didn't draw those, just describe the input and output. So this is the software development process with a validation kit. And we start, of course, as all people should do, but not so many do. We're analyzing the libraries and the tools to make a safety plan, which is somehow also written in the ISO 262. You should do the tool classification and qualification as part of the safety planning, and we do so. In parallel, maybe people can do developing their prototype and hand over this prototype here. When they do prototyping, the output is a prototype. They hand it over here to the software apply here. It's just that this tool and library qualification we pulled out here into a separate process. By the way, green things are verification steps in our process, and blue ones are standard processes that we do perform. Yes, and then once we have the completed software, we have as an output, of course, the software here, and we have the validation kit that we will run to demonstrate that this software is running correctly on the target platform. And that will lead to the safety case, and the safety case will be then assessed from assessor that checks that documents are complete and consistent in those things. and there will be assessment report. Yes, the development tools and libraries come from outside. All other things have an owner here. So we have this, maybe you know these swim lines graphically. We have swim boxes here. The software owner is responsible for prototyping and for the prototype and for the software. So we don't change the software, we will have them doing it. And we will have a hardware owner that gives us a hardware interface. And of course, Validas is currently doing many things here to make the things safe. But as I said, in the DIA, we can also negotiate and bring other people into this game. Yes, where do you see reverse engineering here? Are there any errors going up? No. This is not a reverse engineering process. We call this here a software completion process. So the prototype gets in here, and the software comes out here. So everything goes down. It's a forward engineering process on this graphical representation, I would say. Well, let's look to the software completion process. So this box here, those boxes have sub-processes. And let's look to the software completion process. Yes, we start with the requirements that we get from the product owner. And we start with the hardware owner that also might have requirements here. And we specify them. And then we have these use cases that describe the requirements. And then we think about the architecture. And of course, here you see the only reverse error. We have an existing prototype, and we will use this architecture. We will find out this architecture and re-engineer this. But we are coming from the requirements and having then this feature model describing the architecture. And from the architecture analysis, we will also have some mitigations for the risks and that go into the implementation here. And here you see also the difference between gray artifacts, which are just documents, Word documents, PDF documents, and the orange artifacts, which are modeling elements. And we will, when we specify the requirements, we will do this in the TCA model, in the use case model of the TCA. And we will use feature model and mitigation model to describe the architecture and the threats and the risks. And you see here also that the TCA model is then part of the verification and the QKit creation or validation kit creation. And this is all model-based. You will see in the next slides even more how model-based this process is. Okay, let's have a look to the requirements. Well, I said the requirements are modeled within the use cases. So, for example, you might have a requirement to schedule 12 different tasks within 10 milliseconds. So this might be a requirement that you might have within your system, and then you describe this, and of course the risks is that you are delayed and that there are some other tasks interfering with you, and those are the typical risks there. And you model this as potential errors and use cases. And you might have also hardware-software interfaces here, and there's a verification review with criteria that is performed here. Well, we can, and you can again look into our compliance report, see all the compliance argumentation. And that's how the process looks like. So we start with specifying a frame where we describe the generic things of the software, the name and the version and those things. And we specify the use cases and also the parameters. The parameters are the environment constraints, so how to use it on the hardware, which hardware to use, and those things. The hardware interface goes into the parameter specification. And then we have these environment parameters, which are part of the validation kit. And we have also the potential errors, which are the risks, where we have some default errors. When you look back here to some TCA model, we have here execution is blocked, deadlock, live lock, all these things that we should analyze from the ISO 262. We have here as templates there we can reuse within the analysis of the requirements here. Yes, let's come to the architecture. The most interesting part, I think, that's really how we model it, and I described you how we model it. But there are also all these analysis, how to analyze that your architecture is really safe. Yes, and as I said, we do with static analysis, and here using abstract interpretation, which is a cool thing because it can infer the values ranges and those things. And we describe the module hierarchy, the types, the folders, the files, everything that consists of the architecture we describe here. And even for global variables, we have constructs to model them and to see how they are used, read and written, and things like that. So that is all thing. We have the data and the control flow in the model within these functions. We have not the semantic behavior, so we cannot say run or compute in our model. We just have the dependencies in the model, the data and the control flow. Yes, that is what we describe in the architecture, and it looks like this. So we describe the model structure, and you see here the artifact flows, and you see here some dependencies. So first we start with the model structure, and then we specify the types, then we specify the interfaces and the functions, and then we specify variables and states and implement the requirements by mapping the use cases to the architecture. And this is a nice thing, and you see everything is based on the TCA model, which is used heavily in all the process. And some submodels are created from the different steps around. An interesting box is, of course, safety analysis of architecture. So this is the most challenging thing. How can we find out if the architecture is safe? And we do have some processes or some analysis defined, which we do. We have, I think the most interesting is the risk simulation. This is somehow when we insert a potential error into a feature, we can see how it propagates through all the architecture into the use cases. And then we can see how the use case is affected from potential errors. And interestingly, this is a very similar thing as we do with the TCA since many, many years. We always have this feature, and we call this the inferred errors. But this is a very good way to analyze the risks of a software architecture and see how they propagate, how they propagate. And we can also add mitigations, meaning checks that the risks don't propagate and that we identify the risks. So this is really something that we'll do within the safety analysis of the architecture. Okay. Oh yes, this is a model-based engineering process here. Well, unit design and implementation, this is maybe the place where you just see how we translate the prototype into the implementation. And of course, the functions are then the feature trees, the basic leaves in the thing, and we use the comments from the software to specify it. And if we don't find them, then we need to understand it, and if you cannot understand it, then we can't do it. Okay, let's look at here. You see here the software prototype that goes into the static code analysis, which then is added to the TCA model. So we don't plan to build this model all manually, even if in the first phases we do it, because we don't have the tooling right now. But in principle, when we do the Linux analysis, we won't do this manually. We will do this with probably with the S3 tool from Absinthe, which is a very good tool and also a qualifiable tool, which is important for us. Yes, and then we can analyze here the risk and the coexistence and document the implementation. And here you see if we find some mitigation, some potential errors that we want to change the software. We think this is really dangerous, you missed here something, or there's a bug into it, or a risk or something, and then we can provide to the software owner the mitigations, and let's say we create a ticket for him, and he will then implement this. So we will not change the Linux kernel. Currently we don't have any Linux kernel committer in our team. Maybe this changes in the future, but right now we don't have, so we are relying, and we don't want really to break the system here or do something else. We just say, this is not safe, please correct it. Well, unit verification, I think this is quite standard. We need to check, of course, with testing and freedom from interference. And resource constraints are also important, that we manage to keep in time and space. And of course, very important, the testing which is done on the target. And here you see how the process for applying the QKit, and this is a green one. We take the validation kit, we plan the validation, meaning we select the features, we confirm the use cases, and then we have the test plan, and then we run the test cases with the software and libraries, and the hardware interface and the tools, and we get a test report. and TCA model modified, and then we generate all the software documents. We have that software unit verification report, the embedded software verification report, software integration verification report, software target test verification report. So all those things come from the report generators that we will need to create to be ISO and other safety standard compliant. Yes, we have also supporting processes, and that's the last process slide. You see different things, change management, configuration management, documentation management, development interfaces, where we create the DIA here. And this is the safety processes that are within the process modeling tool, therefore they are orange. And we have requirements management, which is based on the TCA model. And of course, from the software owner, we need to have access to their change management, being able to create some tickets, and also they should have something like a configuration management system. If the software is not under configuration management, it is not okay. Yes, we have already the compliance here. Why isn't it? Of course, we have for 6. Chapter 6 is missing here somehow, but then also these supporting processes we also already have. So we know what we do with our verification validation technique and tools is compliant to 8, 9. So this is a basic process, because this process of verification validation is like a sub-function, like a module in the ISO 262, because they call it in many places. They say you should verify this. In the next phase, requirements should be verified, architecture should be verified, and always according to this process. So this is very important to be compliant with the standard, and we have this already. Well, maybe that's why you are here, to look a bit to the Linux kernel. And of course, we cannot show it completely, but at least we have had a look to this feature, live kernel patching. Do you know what this is? Some of you know it, others not, so I explain you. Live kernel patching is the possibility to update the Linux kernel during runtime. And this is crazy. So if you update your PC, you have to shut it down and restart it, and then it is updated. But in Linux, it is possible to do this live kernel patching. And how is it done? They have, for every function they call, they have somehow a scheduler that say, okay, I'm now calling this function and this place. And this scheduler has a table, and if on this table there's another new function, then they will just call the new function instead of the old one. So in Linux, it's possible for every single C function to have a patch. And that's exactly realized by this Linux kernel patching. And well, first you load the new patch, and then you decide, okay, now we switch, and from then on in time, you always call the new one. So this is how the feature works, and well, it's understandable. You can also read in the code, and you see here there's a lot of documentation within the code, so it looks really good and readable. There are some structures here, some interfaces. Well, here, for example, KLP ftrace handler. There's no specification for the ftrace handler. Well, nevertheless, the code is readable, quite understandable, with many comments in it. So, hey, I think we can complete this here and add the specification for the trace handler. And another thing regarding the coding style, you see here a goto. Many people are allergic on gotos. Well, but is this bad goto unlock? And I think if we have many nested ifs instead of a goto unlock, might be less readable, less understandable. So I don't complain about this. The ISO 262 says you shouldn't have unconditional branch jumps. In principle, goto is an unconditional branch. But what is here? It is guarded by a condition. So it's not an unconditional branch. This is an unconditional statement, but it's guarded. So I would say in this case it's okay. And of course it's only okay if unlock is in the same function. With unlock is a different function, you have a second entry point, and that's not good. So we should have only one entry point in every function, which is also required from ISO. But if you have only those things locally, I would say this is okay, this is readable, and this complies with our coding guidelines. Even if, and I admit this, there are some curly brackets missing. So it's okay to have this abbreviation here, but these brackets are missing, and well, I would add them if I wrote this code, but it's not necessary, and maybe it's a line less or something like that, and therefore people might find it useful to do it like this. Okay, Linux kernel patching is about 1,000 lines only, so it's not a too complex thing. Of course, it also relies on other functions like lists and other helper elements that are included here, mutex exclusions, and it should be synchronized and things should go well. Well, how does the architecture look in the TCA? We have the Linux live patching thing, which is implemented in a core.c file with several functions here. Those functions depend on internal modules, for example, for mutex and for lists and other things. And then we have the dependency here. So the find object module function depends on the is module and the mutex. So this is, of course, important to switch on the right moment and switch all together and have no other process interacting, and therefore they use semaphores encoded as mutexes, which is good and safe. And this is something we can describe here. Also, we can describe configuration parameters in the model. So it describes the architecture of the patching feature. Okay, here's an example of the lists. There are many list functions. So I'm not sure why to use them all or how they are used. But if we would have the call tree, we would see if every of those list functions is necessary. So according to me, you just need insert, delete, and check if an element is in it. But obviously, some people had more or other thoughts on lists, but it's not prohibited to have many list functions, so why not? Yes, there are some other code examples, and I think we can drop those. You see a bit of parameterized codes and return within the code. And some functions that don't have signatures here. Well, nevertheless, here there's a specification there, and you see that this is really, in this case, using mutex things to log things and then work on it. So I think this is understandable code. Here we have a list thing, something a bit weird, which we don't think lists are checked somehow for duplicates, but not for all of them. That's a bit of strange behavior. So maybe if we re-engineer the specification here and create systematic tests, we might find a bug there. So I'm not sure about it, or we haven't dig really deep into it, but this looks a bit like a spell, I would say. Maybe if we dig into this, we can report a bug there. Maybe it's desired, but it's somehow a strange behavior. Yes, these are the questions that we do have requirements for it. So how fast should this go? How frequently should this go? We have even found test cases for Linux tests here. These are test cases for the live patching feature. But we miss a bit the equivalence class is the description of the test cases there. You can read them and say, okay, this is a module we are patching, this is a function we are patching, and then we do the patch, and then we check something. But why they're doing this, and why does it suffice to test this, and when can they stop testing? Do they have coverage achieved with this? That's not clear, and that's something where I think that we need to complete Linux implementation, because with this, it's not safe. Maybe it's safe, but you don't have a driver's license, so it's not compliant. Might be safe, but it's not compliant due to those unanswered questions for this feature. Okay, I think for a summary of Linux, in the kernel, we have found 300,000 lines of code. In total, I heard also some numbers about 25 million lines of code. So this is really a huge system. If you count all other drivers and things like that, then they are probably really 25 million lines of code, and then you can understand how complex things are. Linux, the kernel patching is only 1,000 lines, but there are so many features and so many drivers and so many modules. And hey, that's a big challenge. We can do this in principle. We have a plan how to do this, but we should concentrate on the relevant parts first. Maybe we start with the memory management, which is about a critical thing in the Linux implementation, and find out those things. And it's of course much work. And well, I said already, I think this is a safety plan, but no business plan. So I think it will be hard to convince Linux people to say, okay, next 5 years we do only validation. they will not do this. To go to a company and say, okay, dear OEM, we want to make your Linux safe. Can you give us 50 millions to do this? And we will do scale up and do this for you. Well, probably also not so realistic case. But if we see what they pay for commercial operating systems, it might be a good deal for them. Okay, well, that's a summary. Don't worry about safety. Be happy with Validas. Of course, we are always happy here, and we also hope you enjoy this evening here. And we say there is a safety plan, and we are creating DIAs, and we are working with customers not on Linux right now, but on other software libraries which are smaller. And it's good to start with smaller things, but nevertheless, we have developed this safety plan within the Linux Foundation, and we'll discuss it within the Linux Foundation, and also get the opposite. So there are other people that don't want that Linux will become safe, but we think this is a safety plan, and this is a compliant safety plan, and it's much work, and we need to improve probably we need to improve and complete the Linux implementation by completing this specification here, and maybe also some small changes in the code. Well, next steps, as I said, we have argued chapter 6 and some parts of chapter 8, but there are some things which we have just added to the processes but not formally argued. So there are some chapters we need to argue. One chapter we argued in a day, so it might be a week or two to complete this. This is not really too much work because PMT tool is quite efficient in doing this and helps a lot. It can even generate you a structure for the compliance argumentation based on the requirements. So we are quite fast, and customer asks us, can you do the appendix 6C for configurable software, which is really a hard compliance argumentation, and you can find it there. And it took me a day to argue this. So it was really something good to argue. And of course, I could only do it because I had a good tool, and we have a good process that can handle configurations, calibrations, those things. Okay, well, next steps is then, of course, to look to more examples in the Linux kernel. And we have been asked to create an offer for some parts of it. And we are currently analyzing with abstract interpretation the code to determine how many features belong to this part of the Linux. And then we can make an offer and say, okay, these are only, these are 2,000 functions. For every function, we guess we need to have within this amount of time, and then we can make an offer for it. So nevertheless, we are in a position to create those offers for parts of Linux, of course, not for the whole one, but this is then to be seen as a risk reduction. So within the next year or years, we will not make Linux completely compliant, but we can reduce the risk by focusing on critical parts and by somehow completing. And this is really a rigorous way of looking to software, because it forces you to look to the specification, it forces you to look to the test cases. This is really from the model guides you to make it safe, and or to increase the safety by reducing the risks. And that's where we are. And we are, of course, working also on the business plan, and with Linux community, ELISA working group, we are discussing how to do this, how to make progress, and we are offering this, and we will see what comes out within the next year or month. Okay, that's it. Then thank you very much. Let's get together, have a nice evening. We have a bit prepared some food outside, but first I want to have some questions and feedback from you. So in case you have questions, we might record them. We might also put them away afterwards if you disagree, but I would be happy to get some questions or discussions with you. Thank you. Yes, Momo?
So first of all, thank you for this enlightening presentation. I learned something new, that's for sure. I didn't aware of existence of such tools for qualification. But and it seems that this is really applicable to smaller software components. But when we think about Linux, and we need to get some sort of reverse engineering, I suppose, here, in the sense to define requirements first, or to use, let's say, POSIX as a starting point or something like that. Because that must be like a starting point, right? To qualify.
Well, I agree with you that we need to do some re-engineering to find out the architecture and document it. With the requirements, I a bit disagree because I think this is something that should come from the system provider. They should say, I want to use this and this feature or aspects from the Linux system. I want to have the file system here, POSIX, or I want to have this and this, and I want to be able to do this kind of scheduling or this and this filterable interference, semaphores, whatever I need as a feature. These are the requirements that they need. So we will not be able, and we're not aiming at making Linux completely safe. We want to be able to make Linux usable in a safe system. And the system requirements will be always coming from the system, and we need to map them to the Linux requirements that we have for the architecture and all the helper function. So it's not the aim to make Linux generic requirements for Linux, but we will have this from the specific ones. And regarding performance, so we have our performance guy here, gun on the back, Alexander. You are a performance guy, and you think we can improve TCA to make it handle big models?
Yeah, that's realistic. So we have a lot of things in mind how to do that. And
Yeah, so that's why we are working with you. So thank you. There was another question.
Are you in contact with commercial Linux provider companies like SUSE or Red Hat or whatever it's
We are
called?
currently working with the ELISA working group, and we are with some users that apply this in the automotive domain. But I like to present this on a Linux conference if there's a possibility to get there. I'm not aware of the next ones, but I think this would be very interesting to get the feedback from the real people and discuss it with them and say what needs to be done with them. So this is just the user's point of view and the safety point of view, but I also like to get the feedback from the developers.
There was already an initiative called AGL, Automotive Graded Linux or something.
Yes.
Are you planning to work with them? I don't see any updates since long time in that.
Let me comment on the was we don't work with automotive graded Linux, and there were some tries to make Linux compliant to some IC 61508, which we could do in the same way as we're doing for ISO. We just need to argue all the other requirements, but in principle the process is the same. And why didn't they succeed? So they succeeded in two, they were failing in two reasons. Mainly, I think, because they didn't have a process. So we have these kits that test the system, and we have the model. So we can say, yes, we satisfy by doing this. So we have something that adds value to Linux. And if you just have Linux, how can you argue you document or you have some added value? You don't. So this is one thing, we have something. Of course, it's right now our IP to work with this, but I think that's okay if people building a car that they using our tools for that and our help. And the second thing is, I think that there is some, maybe a mismatching between the philosophy of open source and free foundations and some safety standards, which cost a lot of money and do a lot of regulations and things like that. So there was rather a fight against the ISO, saying this is a bad standard and this is a bad standard here and doesn't do this, and we are at Linux, we are much better than this standard. And this is not a way how to convince safety experts. So I think these are the two reasons why those activities have stuck. And with our approach, we are coming further because we are friends of safety standards. We are safety certified to some aspects, and we have something that we can add to make it safe. Yes?
Maybe a way to start would be to address where most of the Linux code is drivers. Drivers are usually written, and maybe that would be
good idea. Yes.
Yeah.
If you make really a lot of money, remember about me.
Okay. You will get an extra link. I will remember you. Yes, that's a good idea. Thank you.
That's one of the main concerns, because drivers are running in the same other space as other applications. So how to handle freedom of spatial interference.
Yes, this is something that the static analysis tool can help with. So they can analyze, let's say, if you are within the range of your address space with the pointers, or if you do crazy things that can go wrong. And in case that the static analysis tool cannot say it's safe, then we are still humans to look at it and say, okay, this is really hard for the tool, but we can say it's safe because we have understood it. And if it's not understandable, we will reject it. So we can even do more than all the tools can do because we are humans. We are not artificial intelligent, we are hoping to be
natural intelligence.
Natural intelligence, yes.
In the ISO standard you will find lots of method tables that, depending on the ASIL of your requirements, give different recommendations for methods.
Mm-hmm.
Is this selection of methods for your process also supported by this kit, or do I have
yes,
to do this by myself?
We have in the PMT tool we have a tailoring mechanism. So we have terms that can be evaluated from the tool, and if a method is only applicable for ASIL D, and if you choose ASIL C, this method will disappear. We don't need to create the document, so we will do other steps. So what we have presented here is up to ASIL D, so we cover everything. But for those things that can fall away, we have defined some Boolean terms which are based on our process parameters and can be evaluated. And that was the one step in the tailoring and the PMT tool. And we can also work with other things. So that's something that we have from our formal methods background. We just added an interpreter of terms to it, and then that's why the PMT tool is so slow.
My question is related to this live patch. What is your conclusion? What did you draw as a conclusion? Is it safe, not safe?
Well, we haven't validated it. I would say we can make you an offer for it. So we that is something important. Yes, I would say it's manageable, but we haven't done it completely. And I think it relies on lists, and we should have a closer look which functions of the list it's using and how. But we could do this. So that's not a problem that we cannot use live patching in the car. So if you design your next car, you can consider live patching, and remember Validas said they will be able to make you an offer. And if you're clever, then you ask before you decide to do live patching for the offer. Maybe it will be expensive, I don't know.
Yeah, but with live patching, it's not enough to just change the code. You also have to change the whole argumentation, and the whole safety case needs to be regenerated for this modified system.
Yes.
Right?
Yes.
Meaning a lot of things have to be redone, like safety analysis, testing, and whatever.
But we are rebooting automatization, and there's something, and that's what the kit will help you, because there's a test automation unit in it, and you can then run the test automatically, and you can also do many analysis. Also incrementally, the model supports incremental analysis and things like that.
So the model is also connected to a development tool chain that you can use then to do the process activities.
Yes, so at least we plan to get the changes from the code into it, and well, then we can see whether we also automatically add the specifications there in a way that the model is just representing the source code, but currently it's not so closely integrated into the EDEs, but I know that Alexander is also working on IDEs, and he will help us to include and integrate this further, that we can have an IDE for the source code that also has information for the model in it. Yes? So many questions. You deserve a lot of food afterwards.
You mentioned you have to concentrate on the important parts of Linux.
Yes.
So what do you do with the non-important parts to assure that there's no interference with safety?
Very good questions. We just reduce the risks there. So currently, I would say this is something where we can do something like a growing QKit. We have the notion of a growing QKit, let's say, for the GNU compiler. It just covers some features of it. And if another customer adds more features and wants more things, then we add more features. And then the QKit for libraries, for example, we have growing QKits. And the more we get requests, the more we extend it. And the same will happen with Linux. So if somebody is using 5 functions of the list, we will only qualify those 5. And if another customer uses 2 different, we will add those. And
but this is for the safety functionality that is used, but maybe there are different things like drivers, whatever, that are not used for safety functionality. So how can you guarantee that these parts that are not used for safety functionally do not interfere with the safety.
We don't want to go into prison. We don't guarantee here. We guarantee only what we have really qualified. And if we have everything qualified, we guarantee. So other things are the risks from the system perspective. And if they said, well, with the file driver and I/O, we had bad experiences, can you make this safe? Then we can make it safe. So these analysis has to come from the system. We don't guarantee these things.
Have you done some experiments on how much you need to change the code of Linux in order to make it safe? Because I imagine if you do a safety analysis on some component that was developed, let's say, randomly without any safety requirements in mind, they will cut the safety analysis guys will tell you you need to build in this safety mechanism and that safety mechanism, and you need to protect this variable and whatever. So I imagine that the code needs to be changed dramatically to make it safe.
Well, I cannot judge how many changes there will be necessary. My first impression is we should add a lot of comments. But this might be uncritical changes for the community. Yeah. But I agree, if there are risks that we should do some more defensive coding or some additional safety mechanisms. We said we will have mitigations for risk, and we say in this case this happens, we need to do something. We want to bring it. We said it's 2020. We don't have experience right now so much. Nevertheless, we are already in the contract phase to do the first safety element out of context in software according to this process. So there's a good confidence, and also the other OEMs here in Munich have seen this and say, well, that's a good process and will be compliant here. Okay, so no more questions, and I hope that everything is outside with the buffet. You are welcome to have something to eat and drink there and have a get together with us. So thank you very much once again, and have a nice evening.